Throughout this course, we're going to talk about different substances and elements, and to do this, instead of writing out the name each time um, or using extra words, we're going to use what's called isotope notation. So today we're going to talk about isotope notation and what that means and how to use it. At the end of this, you're going to be able to determine the number of protons, neutrons, and electrons an atom contains given the notation. You're going to be able to determine the mass and charge of an atom given the isotope notation. You will be able to write the isotope notation for an atom, and you're going to explain differences between isotopes and ions of an element using isotope notation. So you'll be able to give that to me. So for starters, we're looking at the periodic table, and when we use the periodic table, there's some things we need to be familiar with and know. So first, we have at the top, molybdenum is going to be our element names. Everything is shifted, I apologize. Our element name is here, which is molybdenum. It has an atomic number of 42. Your atomic number is the same as your number of protons, always. No questions asked. Your atomic number, your number of protons is always the same. MO is going to be my symbol. In every symbol that you see, you're going to have a capital letter. If there's one letter, it's going to be capital. For example, carbon is a capital C. If the element has two letters, your first letter is going to be capital, your second letter is going to be lowercase. For example, argon has the symbol of AR. Capital A, lowercase r. This is so when we write out chemical formulas, we know where one element stops and the next element begins. For example, this capital C, capital O is different than this. So this is carbon monoxide. CO, carbon and oxygen bonded together is carbon monoxide. This CO is cobalt. So really important we write symbols correctly. And the last thing you're going to find on your periodic table that we're going to use often is your mass number. And this mass number is going to always have a decimal, unless you get down to the really big numbers, then it doesn't. But then we're talking 200 something or other. But most of the time there's a decimal there. This is your mass number. So a number that's bolded, typically bigger, this is how your periodic table is arranged, is atomic number, the decimal number, written in smaller font, bigger number, smaller font, smaller number, larger font. This is going to be your mass number. So this is what we're going to use when we talk about isotope notation. So when we look at the mass for an atom, I guess, the reason there's a decimal here is because this is the average atomic mass for this element. And then begs the question of, why is there an average? Why can't I just have oxygen has a mass of 16? Why is it 15.9994? I think is oxygen's average atomic mass. Why is there this decimal? Why isn't it just 16? And the answer to that is because we have these things called isotopes of an element. An isotopes of elements are atoms with the same number of protons, but different numbers of neutrons. So atoms of the same element, that's where the protons come in, with a different mass. That's where your neutrons come in. For example, oxygen has, we have oxygen 16, which has a mass of 16. 8 protons, 8 neutrons. We have oxygen 18, which has 8 protons and 10 neutrons. How do I know it's 8 protons? If you look at your aperiodic table, you'll see the atomic number for oxygen is 8, which means there's always 8 protons, which means my neutrons is going to change. So the mass is going to be written here. So this dash is going to always have the mass at the end of it, and you're going to take your mass number minus your atomic number to get your neutrons. Or yes. So mass number is 18 minus my atomic number, which is 8, gives me 10, and that's going to be neutrons. Okay, these are isotopes. We also have these particles called ions. So isotopes have different numbers of neutrons. Ions are atoms that have gained or lost electrons, leaving them with a charge. So isotopes change neutrons, ions change electrons. For example, A neutral calcium atom. If you look at your periodic table, calcium has an atomic number of 20, which means it's got 20 protons. If calcium is neutral, protons are positive, how many electrons does calcium have to equal 0? And so the answer to that is I have 20 electrons. 20 protons and 20 electrons equals a total charge of 0. So if you take protons minus electrons, you get your charge. If I have calcium with a positive 2 charge, how many protons and electrons do I have? And so because the atomic number is 20, I still have 20 protons. Because my charge is positive 2, I know that protons, 20, minus electrons, I don't know, call it x, equals positive 2. Then we're going to solve for x. So I got to get x by itself. I'm going to add it to the other side because it's negative right here. So I have 20 equals 2 plus x. And I'm going to subtract 2. And I get x equals 18. So that means calcium with a positive 2 charge, calcium ion has 18 electrons. Right? This is how we're going to write a lot of our notation. And so with this, you see different isotopes of carbon. And so if you put this in your notes off on its own, X is going to be your element symbol. The number on the top, they give it the letter A. I really don't care that you use A and Z. That doesn't matter to me. But they use A and Z. A is your mass number. Mass number is always a whole number. This is not your average atomic mass. This is your mass number. This is protons plus neutrons, which has to equal a whole number, no decimals. Z is going to be your atomic number, which you can find on the periodic table, which is the same as the number of protons. So using this, I can compare my isotopes of carbon. This atom here, the mass of this atom is 12. Protons, I have 6, because that's my atomic number. Neutrons, remember to get neutrons, I'm going to take mass number minus atomic number. 12 minus 6 is going to be 6 neutrons. And then if I would have a charge, I would put a charge over here. This is where you write the charge. So there's no charge on this, so I know that I have, because it's neutral, I have 6 electrons. So this carbon has 6 protons, 6 neutrons, 6 electrons. If I look at this one in the middle, my mass is 13. What's my proton number? We look at the atomic number. I know my protons, I still have 6. 13 minus 6 gives me 7 neutrons. Is there a charge? The answer in this case is no. So electrons, I still have 6. So I have 6 protons, 7 neutrons, and 6 electrons. So the only difference between carbon 13 and carbon 12 is my 1 neutron. On the end we have carbon 14. So mass is 14. Protons is 6 because it's still the atomic number. Neutrons, 14 minus 6 is 8. Electrons, I still have a neutral element, neutral atom, so I have 6 electrons. This is carbon 14. So we can write isotopes as either, I can have carbon 12, I'll write it down here. I can have carbon 13, or I can have carbon 14. Or I can write it like this. Either way works. You need to be able to identify both of them. Remember that this number here is the mass number. So element and mass number is your isotope notation. This guy is just another isotope notation. So I want you to take a second, pause the video after I talk. I want to know mass number, mass, protons, neutrons, electrons. Go ahead and pause the video, get those calculations done, and resume the video and I'll give you your answers. So mass in this case is 36 because that's on top. Protons is 17 because that's on bottom. 36 minus 17 is 19. That's my neutrons. Because I have a -1 charge, I have to have one more electron than proton. So 17 minus 18 equals -1. Here's an opportunity for you to practice. I want to know how many protons, neutrons, and electrons are found in these atoms. And I want to know the mass and charge of these two on bottom. Pause this video, answer these questions. They will be on the next slide, so when you hit resume, you'll get your answers. And here are the answers to those example questions. Make sure that your numbers matched mine. If not, please talk to me. It's possible I could have messed up my calculations as well. So talk to me, and we will get it straightened out. But this is really important to be able to do throughout the rest of the course. What I would like you to do as a review, make sure you can tell me, what does the atomic number represent? Why does the periodic table have an average atomic mass instead of just the mass number, just an atomic mass? And then how many protons, neutrons, electrons does this element have, along with what is the mass of my atom here? Make sure you can answer those, and I will see you next time.